Let's come to the next concept, which we call highest common factor, HCF. The idea behind this concept is simple. Let's take number like 8, 12, 20. What are the factors of 8? 1, 2, 4, 8. Factors of 12. 1, 2, 3, 4, 6, 12. Factors of 20. 1, 2, 4, 5, 10, 20. Some factors are common to the three of them. 1 is common. 2 is common to them. 3 is not common. 4 is common to them. What else? Nothing else is common. Among these common factors to 8, 12, and 20, which one is the highest? The highest one is 4. That is why the HCF of 8, 12, and 20 is 4. The highest common factor of 8, 12, and 20 is 4. So 4 is the factor that is common to the three of them, and that is the highest. 2 is common to the three of them. 1 as a universal factor is common to the three of them. Anyway, that one is a universal factor. 2 is common to the three of them. But 4 is the highest one that is common to the three of them. That is why it is the highest common factor of 8, 12, and 20. Let's consider a very good example of HCF. Let's consider example 1 under HCF, highest common factor. Find the HCF of A 72, 108 and 54, B 36, 54 and 60. Question A. 72, 108, 54. Using long division method, 2 goes in 72, in 7, 3, 6, 5, 4, 2, 7. 2 can no longer go in all, because when you are using long division approach to find the HCF, the difference between that HCF and LCM is that in LCM we use all the available prime factors, but in HCF we use only the prime factors that can divide all the numbers in consideration. The prime factors that can divide 72, 108, and 54 at the same time. That is what is qualified to be used there. 2 divides 72, 108, and 54, and that's why we use it. 2 divides 36 and 54, but does not divide 27. That's why we are not going to use it. No, let's go for 3. 3 divides 36, 1, 2. 3 divides 54. 3 in 5 is 1. In 24 is 8. 3 in 27, that's 9. 3 goes again in all. 3 in 12, that's 4. 3 in 18, that's 6. 3 in 9, 3. Nothing else goes in all. 2 goes in 4, in 6, but does not go in 3. 3 goes in 3, in 6, but does not go in 4. So nothing else goes in all. Therefore, HCF of 72, 108, and 54 is 2 times 3 times 3, which is 18. 3 times 3 is 9. 9 times 2 is 18. For the second question, B, we have 36, 54, and 60. 2 goes in all, as you can see. 1, 8, 2, 7, 30. 2 goes in 18, in 30, but does not go in 27. Therefore, we use 3. 3 in 18 is 6. In 27 is 9. In 30 is 10. What else goes in all? Nothing. 2 goes in 6 and 10, but not in 9. 3 goes in 6 and 9, but not in 10. So that is the end also there. Therefore, HCF of 36, 54, and 60 is 2 times 3, which is 6. So that is that about HCF using long division. Let's consider another approach. Let's consider the same question using product of prime factors approach. For question A, we write 72, 108, 54. We express 72 as a product of prime factors. 2 goes here, 3, 6. Here, 1, 8. 2 here is 9, 3, 3, 3, 1. So this is 2 raised to power 3 times 3 raised to power 2. For 108, 2 here, 5, 4. 2 here, 2, 7, 3, 9, 3, 3, 3, 1. So that will be 2 raised to power 2 times 3 raised to power 3. For 54, it will be 2 times 3 raised to power 3. You see, 54, I just cut it from here. So that is 2 times 3 raised to power 3. So finding the HCF using this approach, so therefore HCF of 72, 108, and 54 is equal to, come here. In this approach, HCF is taken as product of only the common factors in their lowest power. You know, lowest is the opposite of highest. Highest, common factor. So you take the common factors in their lowest power. And what is the lowest power? What factor is common to them? 2 is a factor that is common. 3 is a factor that is common. But you take 2 in its lowest power. That is 2 raised to power 1. 3 in its lowest power is 3 raised to power 2 because 3 raised to power 3 is the highest. So HCF here is 2 times 3 raised to power 2, which is 2 times 9, 18. That is it. You can see it is the same answer we got in the first approach. Let's go to B, that is 36, 54, and 60. 36, I use this table, cut it from here. You can see the 36. So that is 2 raised to power 2 times 3 raised to power 2. 54 is like we have it here. Yes, that is 2 times 3 raised to power 3. 60, let's do it. 2 here is 30. 2, 15. 3 is 5. 5 is 1. Is that? Yes, that's correct. That is 2 raised to power 2 times 3 times 5. This is product of prime factors approach. Product of prime factors approach to finding the HCF. Therefore, HCF of 36, 54, and 60 is, we take the product of only common factor in their lowest power. 2 is a common factor to the 3 of them. 3 is a common factor to the 3 of them. 5 is not common. 5 only exists with 60. It is not common. But the 2 and 3 that are common, we take them in their lowest power. In the first, 2 raised to power 1 is the lowest, times 3 raised to power 1 is the lowest. So answer is 6. HCF of 36, 54, and 60 is 6. And that is that. Let's consider example 2. Find the HCF of 2 raised to power 3 times 5 raised to power 2 times 7, comma, 2 raised to power 2 times 3 raised to power 2 times 5. And 3 raised to power 3 times 5 raised to power 3 times 7. So what we do is put them side by side. 2 raised to power 3 times 5 raised to power 2 times 7. And 2 raised to power 2 times 3 raised to power 2 times 5. Also 3 raised to power 3 times 5 raised to power 3 times 7. Therefore, HCF of these 3 expressions is, don't forget, find the product of all the common factors in their lowest power. 2 is not common to them. 2 is only in the first and second, is not common. 3 is not common. 3 as a factor is in the last and the middle one. So 5 is common, yes. We have 5 raised to power 2 here, 5 raised to power 1 here, 5 raised to power 3. And we take the common factor in their lowest power, opposite of the highest. So we take 5 times. What else is common? Nothing, because 7 is not common. 7 is not in the middle. I remove the multiplication sign. That means 5 is the only answer. 5 is the HCF of this, because it's the only common factor in its lowest power that we have there. Let's consider example 3. Under highest common factor, find the HCF of 2 raised to power 2 times 3 raised to power 3 times 5, comma, 2 raised to power 3 times 3 raised to power 4 times 5, and 2 times 3 raised to power 5 times 7 raised to power 2. So, align them, put them beside each other. 2 raised to power 3 times 3 raised to power 4 times 5. Then lastly, 2 times 3 raised to power 5 times 7 raised to power 2. The HCF of the 3 expressions we have here will be the product of the common factors to the 3 expressions taken in their lowest power. 2 is common to them. We have 2 raised to power 1 here, 2 raised to power 3 here, and 2 raised to power 2 here. In its lowest power, it is 2 raised to power 1 that we take. Times, what else is common? 3 is common, but we have 3 raised to power 5 here, 3 raised to power 4 here, 3 raised to power 3 here. But we take the one with the lowest power, that is 3 raised to power 3. What else is common? 5 is not common. 7 is not common. 7 is in only one expression. 5 is in 2 expressions. So this is the answer. If we want it as a figure, 3 raised to power 3 is 27. 27 times 2, that is 54. And that is it.